Hello everyone, myself Sriyadas. I am a student of Bachelor's of Interior Design, Semester 4 from Faculty of Architecture, Institute University. I am excited to share this presentation with you today. Today I am here to discuss about comprehensive guide to building wiring system. We will discuss about introduction to the building wiring system, importance of it, and technical requirement and consideration of it. And in all together we will understand the summary of it. Introduction of building wiring system. Major topics are historical development of building wiring system, key components, types of wire, modern trends, maintenance and services, and future directions. Historical development of building wiring system. The evolution of building wiring system says how the wiring system has been evolved due to the technology. In prehistoric era, it has been taught how the building used gas technique to lightening their system, whereas in early electrical period, electric systems were directly connected with the current power distribution. The key components are service entrance and main panel, distribution panel and circuit breakers, branch circuits. Types of wiring system. Cleat wiring system. It supports conductor. Conduct wiring system. It is used for mechanical protection and flexibility. Batten wiring system. It is a cost-effective system using wooden battens for supports. Designing an efficient electrical layout needs assessment for the electrical requirement of the building, circuit planning for the efficient distribution of power, layout optimization for the placement of the outlets, code compliances for the electrical codes and regulation to ensure the safety and prevent potential hazards. In wiring system, modern trends are integration with smart technologies, energy efficiency with initiatives, renewable energy integrations, such as smart home integration that integrates with smart home technology, enabling the remote control and automation of the lighting appliances and security system. Energy efficiency technology that optimizes energy consumption and reduce electricity bill. Wireless connectivity that eliminates the need for traditional cable runs, offering the greater flexibility and the convenience in installation. Maintenance and serviceability. Regular inspection and testing helps in ensuring the safety and efficiency. Fault identification and repair helps in addressing the system issue. Documentation and labeling helps for maintaining the future updates. Future direction of the building wiring system will be characterized by increased smart grid integration, IoT connectivity, AI-driven optimization, and a strong focus on sustainability and energy efficiency, all while maintaining the safety and reliability. Smart grids and IoT integration, AI and machine learning, sustainability and energy efficiency, safety and reliability, emerging technology, and etc. Now we will discuss about the importance of building wiring system. Main components are integration with building services, enhancing building functionality, importance of standard electrical symbol and enhancing safety, support and energy management, adaptability of future needs. A wiring system is a network of wires and related components that distributes electrical power from a source to various devices or load, ensuring efficient and safety energy deliveries. Purposes of primary function of a wire system is to safely and efficiently transport electrical energy from a power source like a utility pole or a generator to different point where it is used, such as light, appliances or motors. Integrating building services like HVAC, plumbing, and electrical system with a building wiring system which ensures efficient operation, safety, and a comfortable environment by coordinating their functions and infrastructure from the design state, such like key building services and their integration as electrical system, heating, ventilation, and air condition, plumbing system, fire and safety, communication system. Secondly, the benefits of integration, efficiency, safety, comfort, flexibility, and also reduce costs. Thirdly, the design consideration, early planning, coordination, and space allocation with standard codes, and BMI, which is Building Informative Modeling, is necessary for fundamental integration, power distribution, and management, along with the safety and emergency system. Enhancing building functionality ensure reliable and efficient power delivery, enabling the operation of essential building systems like lighting, heating, and appliances. Smart wiring takes this further integration into advanced system for energy efficiency, safety, and enhanced user experience through the feature like automation and remote control according to the illustration. Some enhancing building functionality are power delivery and reliability, smart wiring and enhancing features, aesthetics and design, future proofing, along with the climate control and comfort, which supports the HVAC system of optimization in living environment, lighting control for advanced lighting control, communication and data network for modern communication needs. Standard electrical system and enhanced safety are crucial for protecting people and property, ensuring reliable electrical performance and promoting cost effectivity. For safety standards and regulation, we minimize the risk of electrical accident like shock, fire, and injuries. This also enhances the reliability of the system, reduces maintenance cost, and improve overall energy system. The detailed breakdown of why these are so important are human safety, proper protection, reliable electrical performance, cost effectiveness, compliances, and legal consideration. In conclusion, it prioritizes standard electrical system and enhanced safety is not just a matter of following regulation, but a fundamental responsibility to protect human life, preserve property, ensure reliable performance, and adhesive cost effectiveness. Energy management supports encompass various strategies and tools to help organization and individual efficiently use energy, reduce cost, and minimize environmental impact, including energy audits and monitoring system and training program. Basically, energy management system means are framework that help organizations manage their energy use, encompassing policies, produced and practices. The key elements are developing and implementing an energy policy, setting energy target and action plans, monitoring and measuring energy performance, implementing energy efficiency technology and practices, continuous improvement of energy management and process. The purpose of energy monitoring and control system is to track energy consumption in real time, identifying the incidents and automated energy management tasks. Adaptability of future needs in building wiring systems should prioritize flexibility, scalability, future-proofing measures like oversized conducts, extra panel capacity, and modular components, allowing for each ingredient of new technology and evolving electrical demands such like design for flexibility and scalability, prioritize quality and durability, consider emergency technology, sustainability and emergency efficiency, regular maintenance and upgrades. Now we will discuss about technical requirements and consideration in building wiring system. Conductor sizing and protection involves selecting the appropriate conductor size and overcut protection device like fuse or circuit breakers to ensure safety and reliable electrical operation, preventing overhead and potential hazard like fire. Conductor sizing depend on the factor like current, voltage, length, and environmental condition, while protecting devices are sized to trip or open the circuit if the circuit exceeds the conductor's capacity. Specialized area requirement for weight location and hazardous area are very essential for protocols of area to unique safety and needs. Control and communication area accommodate modern building and automation of data transmission. Commercial buildings, for example, have different wiring requirements than residential structures, and even within a building, wiring for electronic devices from that need of a heavy machinery have specific needs and regulation. Advanced standards and code. Compliance with update code, staying abreast of evolving regulation and integration them into varying design system. Safety environments adopting the latest safety technology and practices. Ground fault circuit interprets are safety device that protects against electrical shocks by quick shutting off power when they detect a ground fault, and unintended paths for electrical to flow to ground within milliseconds. It requires proper wiring techniques, regular inspections, which can identify potential safety issues before they become hazardous. When designing a building system, key consideration include safety, electrical load capacity, future need, energy efficiency, and aesthetics. Ensuring the system meets the safety standard compiled with the local codes and can accommodate future exploration in crucial. Factors like the types of building, temperature, and the cost also influence the choice of wiring system. In summary, a building wiring system's key find revolves around safety, efficient and durable power distribution, encompassing various wiring types like strategic planning of outlet and switch placement of prevent overload and ensure convenience for the critical infrastructure, technology and sustainable evolution, which is better for the maintenance rigorous, document, follow safety protocols and plan for future expansion. The final recommendation in building wiring system is electrical wiring is an installation of capable through which power is distributed to the various devices associated with electric and structures manner to ensure a continuous power supply which focuses on quality and safety, future-proof installation, professional oversights. In conclusion, a building wiring system is essential for safety and efficiently distributing electricity. It provides networks of wire and components that power appliances, light and other electrical systems within a structure. The system design and installation must be added to safety standards and build codes to prevent hazards like electrical shocks and fires. Thank you for your time. I appreciate the opportunity to speak with you today. Thank you all.